up here, before we go, we need to talk about tubes come in 3 flavors. You have 2 open ends, like the tube you're going to use today. That's like what basically most musical instruments are. Most, like woodwinds and trumpets, they really are 2 open ends. You have 1 closed end. One end is closed, so like an organ pipe, some whistles, things like that. You can also have an instrument where both ends of the tube are closed. However, to hear an instrument that has both ends of the tube closed, where do you have to be to hear it? You have to be inside the instrument. Inside. I've only experienced 1 instrument of that type. 1. They have one at the Exploratorium, but it's not open to the public. It's actually a piece of art. Well, if you're on special tours, you can visit it. It's just where it is. It's built inside of one of the legs of the Palace of Fine Arts. The dome part, inside one of those legs. The legs are basically hollow. They're like storage for different things. But inside one of them, an artist built this musical instrument. And literally, they put markings on the wall where the nodes and the antinodes are. In other words, you hit the node, you put your ear at the level of that. Okay, I can hear it. I put my ear at different other levels, I can't hear it. So it marks the notes. But it's also a work of art. You go on special tours. So I went to an institute at the Exploratorium. That's why I saw it, because they took this in there. But it's one of those things you just couldn't have a general public sort of thing. Remember, the Exploratorium is a museum of science and art. It's not really a pure science museum. It's a museum of science and art. So this was actually a work of art, more than a work of science sort of thing. So you have to be inside it. Now, we're going to talk about open tubes today. Next time we'll talk about closed tubes. Okay. By the way, tests will be next Thursday, a week from tomorrow. Test, just goes in the site. So the thing is with tubes, whenever you have an open end, you have to have an antinode. For the standing wave to form, there must be an antinode. An antinode. And again, the fundamental frequency is twice the wavelength of the tube. Sort of. Thing about tubes in air. The actual length of the tube is actually longer than the tube. Sounds kind of weird, isn't it? Remember, sound waves are pressure waves, right? We're going to draw them as the transverse waves. Remember, they're pressure waves. In order to get a standing wave, you have to have reflection off the end, right? Now, with the string, okay, I can see that. They have the note at the end. It's attached. It hits the end. It comes back and forth, just like we held the spring in the middle of the room. How does that reflection occur if you have just air going into air? Well, remember, in the tube is very high pressure air. So remember, it's an antinode, high pressure. The high pressure starts to come out, and when it spreads out, the pressure goes down, and it hits the air on the outside, and you have this differential in pressure, but it spreads out some. And what happens is when you have that difference in pressure, the wave gets reflected. It's almost like hitting a wall. So you get the reflection because there's this difference in pressure. But it spreads out the end. In fact, that is the purpose of the bell of a musical instrument. The bell of the musical instrument. Because you take a clarinet. Most people think it's to make it louder. Not really. Because if I took the bell off a clarinet, it sounds the same. Whether it has a bell on it, you take it off. But there's actually a very famous musical piece for clarinet. During the piece, the clarinet soloist takes parts off of the clarinet and just plays. It takes off the bell, then takes off the lower piece, takes off the upper piece, and finally it's only left with a mouthpiece at the end. It's a very famous clarinet piece on that. But when they take off the bell, it just sounds the same, because the bell's purpose is to actually smooth out that transition from high to low pressure areas. So it's meant to smooth out the transition to get a better waveform inside, so you get a better note. So the bell's purpose is not like amplification. It's not like a bullhorn. It's meant to actually help get a better sound, a better wave inside on that. But notice, still the same, twice the length of the tube. The only difference is we now have antinodes at the end. So I have an antinode, but again, How much of a wave would be our fundamental? How much of a wavelength? Still be half. It would still be half. So we start with one node in the middle. So this part, there's a quarter wave. A quarter wave, it's still half a wavelength. But before, when we had one node, and this kind of things, one antinode, one node, we're at F1. Length is still half the wavelength, still twice lambda. We go to the second one. Now we're going to need, how many antinodes do I need there? 2. We also need 2 nodes. So we go from 1 node to 2 nodes. It's the easiest way to draw that. Always have an antinode at the end. So we always have this quarter, quarter, one more, that's 1 full, twice F1, lambda L. Now what did I say? The rules are the same, mathematically the same. The only difference is we have, instead of being nodes at the end, we have antinodes at the end on that. So now we go to 3. Like that. 1 quarter, 3 quarters, 5 quarters, 6 quarters. So that's 3 halves. 3 F1, 3 halves of a wavelength, 2/3 lambda. And so our last one, we're going to have 4. Like that. Just like I had before. Twice the wavelength, half the length. So exactly the same. Exactly the same. Questions? All right, we're going to start our exercise. So what you need to do is basically set up your things. Do not come get a whirly yet, because the temptation to make noise with it is too much for anybody. Just have to twirl it. Okay, so we'll get those. But what you want to do is set up exactly the way you did last time. Remember, you're going to go into the probes and sensors, flying microphone, the FFT graph. We'll set up. Anybody need this up before? Still need that up? Okay. And then I actually have a table for you guys to put in your notes on that. We're going to talk about what we're going to do during our investigation of the fundamental frequency here.